This is going to be a video dealing with probability on identifying permutations and combinations. First thing we'll talk about is a permutation. This is when you're going to arrange some things and the arrangement of objects, or this is the arrangement of objects where order is important. Okay, so this is where order is important. And so look at this first example here that we have. We have 5 people are waiting in a line for customer service, which may close soon. Is this order important? And the answer is yes. And the big reason why is because of this closing soon. Okay, so we could put yes. And the reason why is the closer to the front you are, so closer to the front, the more likely you're going to be served. Can't spell, sorry. E-L-Y, there we go. Sorry, I was supposed to say likely to be served. Okay, so if you're in the way back, you have less of a chance of getting to customer service than the person in the front. So the order is going to matter here. The next one says a person sets a 4-digit PIN on a debit card. Is this order important? The big thing here is your 4-digit PIN. Everything that's a PIN or a password is going to be important. So here we can say yes, because the card will not work if you put the numbers in a different order. So the card will not work if you put the numbers in a different order. I know it's a lot to write, but go ahead and pause it and get that finished writing down. So when we take a look at, with our notes, we had a quick reference. We have this area right here about permutation. We'll just talk about the permutation right now. This is not everything, but these are some things that to look for in the problems. In an order, rankings like first, second, third place, etc. Specific roles or jobs. If you're lining up in a specific order, like that first one talking about, when it's about to close, when the customer service is going to close soon. And the big thing, passwords, IDs, usernames. Okay, that second example we talked about where we have a PIN, like the 4-digit PIN number. Okay, so your combination, on the other hand, is going to be an arrangement of objects where order is not important. Okay, so this is not important. Does not matter what order these things are going in. So here we have 4 students who are chosen from a class of 20 to work on a group project. Is this order important? And the reason, and the answer is no. And the reason why is because it doesn't matter who's chosen first, second, third, fourth, and fifth. All 5 students are still going to work on the project together. So here we can say no. They all still get to work on the project. A lot to write. We've got to explain it so we understand. Okay, pause it and get that finished writing down if you need to. The last one is basket will be filled with 5 types of fruits chosen from 15 available. Is the order of this arrangement important? And again, no. All 5 fruits are still going to make it into that basket. So it doesn't matter what order. If I choose a banana first and a lemon second, they're still both going to the exact same place. So here, say no. All 5 fruits are still going to go into the basket. Go ahead and pause. There you go. Pause it and write that down. I figure I could probably write a little less sloppy if I pause it. Okay? So they're also going to who cares what order they go into. So, I forgot about on this second page. We have that quick reference. Exactly what we just talked about. Okay? So, remember, this is not all-inclusive. It's not going to have every single example you're ever going to see. All right? Here, let's take a look at this first example. We have that Mr. Diaz attempts to log into his email using the password lovemath123 ! But failed because it was the wrong password. So he tries lovemath321 ! And successfully logs in. So we want to know, is this going to be permutation or a combination? Again, we have this whole ordeal with a password. A password is always going to be permutation. Big reason here is we've got the word password. Okay, if you take a look at these two, that order is going to matter. He put 1, 2, 3, then he put 3, 2, 1. So once he changed the order, it worked. So he puts it in the wrong order. Order matters. Permutation. The second one, a movie theater is hosting a raffle of 500 participants to win tickets for the Super Mario Brothers movie. Only 3 winners will be selected. Is the order of these 3 tickets going to matter? Does it matter which one's drawn first, which one's drawn second, which one's drawn third? No, it's not going to. I'm writing no. Let me get that fixed. So we're going to have a combination because, again, it does not matter. They're all 3 going to make it into this movie. Who cares who's first, second, and third? Number 3, Mason is trying to check out a book at the library and must provide his student ID consisting of a letter and 7 numbers. Here we go. Student ID. Big thing. Order is going to matter, so this will be permutation because of that student ID. Anything in a unique order, there's that word order, we're going to have this permutation because of that ID in this problem. All right, next problem. Rob and Mary are planning trips to 9 countries this summer. They're trying to decide which countries to visit out of 18 total. Doesn't matter what order they go to these countries in. So they choose a 9. Doesn't matter which one they go to first, second, third, etc. And it does not matter if they go to, let's just say, they go to France, then they go to Ireland, then they go to Germany, and so forth. It doesn't matter what order they're going to go in. They're still going to make it to all of these countries. So this is going to be a combination. And if you want to, we can just, since it's on another page, order of countries doesn't matter. We'll put does and then not. All right, on number 5, a technology company interviewed 45 applicants for the same computer programming positions. Company must decide which 3 applicants they should hire. Now, does it matter what order they hire these 3 applicants in? No. The reason why is because of the same computer programming position. It's the exact same position, so whatever 3 they choose, they're going to get the same thing. So it does not matter what order, combination. Okay, we could put here, still all getting hired. For the same job. Okay, everybody's getting the same thing. Nobody's benefiting from being chosen first. All right, so number 6. Now we have a software company interviewing 15 applicants for 4 different jobs. Okay, so this is going to be a big thing. We have these 4 different jobs. We have a computer programmer, software tester, maintenance manager, and systems engineer. The recruiter must decide which applicants to hire for each job. They are not all getting the same job. So let's take a look at this. We have 15 different applicants. So we got applicants number 1 through 15. Let's talk about these 4 different jobs we have. We'll put C for computer programmer. Okay, let's say that we choose that. That's the first person. Okay, then we say, okay, we got a software tester. And that's the second person. It's going to get the software tester. Then we have our maintenance manager. And let's say the third person we choose is going to get the maintenance. And let's say the fourth person that we choose is going to get the systems engineer. Okay, so the first 4 people we choose, this is the order that they're going to go in. Now, let's say that we decide the third person is going to be the computer programmer. And let's say that the fourth person is going to get the software tester. And the first person that they choose is going to get the maintenance manager. And the second they choose is going to get the software engineer. Systems engineer. What we need to see here is that out of these 4 people they choose, we're assigning them a specific role. And we looked at the previous page right here, okay, specific roles or specific jobs. Okay, this is going to be a permutation. So it matters which order we hire them in. So we got permutation. All right, last one. We have 7 bands volunteer to perform a charity concert. There's only enough time for 4 bands to play. They need to come up with this concert lineup. So out of these 7 bands, does it matter? They're going to choose 4. Does it matter which band they choose first, second, third, and fourth? Now, they're not saying, anything about timing, or they're just saying we're going to take these 7 bands, we're choosing 4 that are going to play, period. And so it doesn't matter which one they choose first, second, third, and fourth, because all 4 bands are still going to get to play this concert, regardless of whether they're chosen first, third, fourth, second, they're still getting to play the concert. So here we're going to have a combination, and I'm going to pause it and write down basically what I just said, and that way you guys can write it down. Okay, so here we have the same 4 bands still going to get to play. It does not matter what order you choose them in. So this is going to be your combinations and permutations, just identifying is the situation a permutation or a combination. Then we'll have another video and notes on then how to actually calculate the probability.